Welcome everybody. We're in Wadena County in beautiful Staples, Minnesota at Central Lakes College. And with us is Todd Pollema. He's the farm manager, and today we're going to talk about irrigation systems. So for folks that maybe not know, why do you have irrigation here?
Irrigation here on the coarse sandy plains of Minnesota, or where we're at, is almost imperative to raise a sustainable crop on your acres.
Gotcha.
Because the ground is so sandy and the water drains through so fast it doesn't have water holding capacity. So without irrigation, especially on a year like last year, you basically didn't get any crop because there was not enough water. The irrigation helps that immensely. It gives us the opportunity to raise a good crop on these acres.
And you guys grow quite a variety of crops out here, correct?
We do. We raise small grain, which oats, barley. We raise dark red kidney beans, black beans, soybeans, corn, even a little hemp. It's quite a variety.
Some high value crops.
Yes. Our main focus kind of is corn, soybeans, dark red kidneys. There's a lot of dark red kidneys grown in this area. Half of the kidney beans in the nation come from 3 counties in Minnesota here.
It's pretty impressive.
Yeah, it's pretty impressive.
Minnesota pride right there.
Yeah.
Awesome. So last year you had some drought conditions here on the farm.
Very dry.
How often did you irrigate last year?
Last year I was irrigating about every 3 days.
Every 3
a
days.
half inch every 3 days.
Right.
Depending on what we have, soil moisture sensors and other tools at our disposal to help decide when to irrigate. I have a probe that I use myself that helps me decide when to irrigate, but I would say on an average about a half inch every 3 days. The irrigation system that we have here is our only variable rate irrigation system. This is our 3rd year in operation with it. It allows us the ability to variable rate the amount of water that's put on via prescription over the entire field.
So can you walk us through some of the pieces to the system here for center pivot?
So here's your center tower, very basic. This is where your control panel is, and then each set of wheels is referred to as a tower. This particular system is 7 towers long. The full length of the system is about 1,180 feet. The towers are not all the same spacing. There are some obstacles out in the field. You can have wells, you can have power panels, you can have a number of things that would affect your tower spacing.
Gotcha.
So it is, each individual irrigator system is its own design.
And this isn't a high pressure system, correct? This is a
No.
low pressure system?
It's a low pressure system. We have the irrigator drop nozzles on this system. You can also have overhead sprinklers where it'll sprinkle off the top of your spans.
But it's a lower pressure,
Yes,
larger
it's-
water droplets,
yes.
more efficient,
Yes.
less evaporation.
Evaporation, wind drift, things of that nature, yeah.
Well, there's a lot of fancy things on this center pivot. Can you walk us through some of the gizmos and gadgets that a variable rate system would need?
Sure. What stands out with the system, and we should probably look at the biggest thing that the variable rate system will do, is on top of the pipe, which is called a span, you have valve bodies. Each individual drop has a valve body on top of it. That's your control module for your variable rate irrigation. And those valve bodies will be open and they'll close if you do a prescription that wants to put less water on. If one fails, they always fail open. So it'll never
Shut down.
and shut the water completely off. The way these work is, say you wanted to put a half inch of water on, and then in a certain area of your field, you wanted to put a 1/4 inch. So then you would do your prescription at 50%. It would close that valve body intermittently half of the time.
Okay.
So you're only putting a 1/4 inch of water on, so it's closed half the time. And you can do it any percentage you want.
And the zones are set up, so we irrigate, we put different amounts of water in different zones. Is it based on crops that are grown too? Is it based on like your different soils and yield capabilities? The uniformity of the field, does that have anything to do with your zone creation?
Well, you wouldn't do a prescription for your crop,
Gotcha.
or I wouldn't necessarily. More on the undulation of your field or the different types of soil that are in your field. Or we do have one system that the N3 towers run out in a swamp. Well, nobody wants to water a swamp.
Shut them down, right?
So you shut them down.
Excellent.
One key that I think needs to be mentioned with the variable rate irrigation system is you are restricting flow. So then it is required where the wells are, they have to have a variable frequency drive to slow down the pumps.
And that's the pumping plant.
Yep.
Okay.
Yep. To slow down the pumps of your well. And that is imperative, otherwise you'd be running your system at too high a pressure if you shut down a whole bunch of nozzles. So the pump has to go up and down with the needs of what your system.
So all these things are talking to each other. Right?
Yes.
So there's like a control box that talks back to the pump. The nozzle shut off as it goes through.
Yes, and each individual nozzle is wired into the panel, into your prescription, and you could run this system just with one nozzle off if you wanted to. Sweet. We have our water meter, our flow meter. This will show the amount of gallons that this system has used for the year. And now as the system's filling, it's showing how many gallons a minute the system is pumping. So that number will increase because I believe this system is designed for 600 gallons a minute. As it's building pressure, that number will increase.
Does this get sent back to your phone?
Included with AgSense is a app called Wagnet. You can get reports on how many gallons you pumped per time. It'll give you the dates that you pumped, and it'll do a cumulative per month. So I usually do printouts every year on per month irrigation, and then every farmer has to report the amount of gallons they used per year to the DNR, and then there's a certain charge on that. So we report all the gallons that we use. So Wagnet has been a really good tool for us. It helps us a lot because we can just go access the system. It has all of our systems that we run, and then we can generate reports off of that. So it's a very handy system.
So we talked about moisture sensors, and you do the moisture by field method, and you take core samples.
I have the sensors. I also use the probe. I use the probe almost every day.
Gotcha.
We've had a lot of rain the last week. I haven't been probing ground, but I spend a lot of time driving around to fields, walking fields. You're also looking for disease or anything like that in your fields when you're walking them. And I try not to, like, say you go into a field and you have a dip where water would pool and you have a sandy hilltop. I don't probe those spots. I try to probe an average spot.
Typical, kind of like crop scouting. You scout the typical areas of a field, not the edges or margins. And
Yes.
Excellent, excellent. I see a lot of wires and things sticking out here.
So up there is your collector ring. That's what's basically responsible for where your system is and how your system is moving. The wire, all the systems that we work with, are run on 480 volt three-phase. So there's 480 volt three-phase running through all the towers all the way to the end. And each individual tower has its own tower box. And then inside that tower box, it controls the activity for that tower. So the wire is fed underground, comes up through your panel. Once your controls are activated, it goes up through your collector ring, and then the wire just goes all the way down, and each individual tower has your tower box. Then in the middle of the towers out there, in between the wheels on the axle bar, is the center drive. That's what drives your wheels to turn. There's not full power going to those at all times. So there's a switch on top that when the end tower will move first. When that one moves a certain distance, it'll kick in the next switch, and the next one, and the next one.
Kind of keeps it all in a nice line.
Sometimes the end 2 or 3 towers will move 3 times before the first one here will move.
Before it starts kicking in. Got it.
So there's not full-time power running all the way down to the center drives.
That sounds like a lot of fancy circle math that I don't want to tackle today.
Yeah, we don't have to do a lot of the math per se to that. At least
the system does it for you, and it knows when to move the outside and the inside.
Some of those parts do fail on us.
Okay.
And we change a lot of those parts out ourselves. There's a transmission or a gearbox on each wheel. So this one is a 7 tower, it has 14 wheels, it has 14 transmissions on it. Now this particular system is a high-speed system. So what that means is this will move at an extraordinary amount of speed. This system at 100% dry, running without water in it, will do this full 110-acre circle in 53 minutes.
53, okay.
The old system that we had here prior to that took 16 hours to do that same lap. So what you'll actually be able to see here is the variable rate irrigation in action. We just have a demonstration prescription in here. There's 13 drops The first 2 are running at 100%. And then 3 through 16, there's 13 in a row where they will be on 50% of the time and off 50% of the time. And then the rest of the system we have running at 100%. Now, this isn't the normal prescription we use on the field. This is just for demonstration purposes.
So what is this box?
This is your control panel.
Control panel.
I'll open it for you. And it's an Icon 10, and it's a touch screen. So you can turn your water on and off from here. You can, now that I turn the water on, my setting was at a 1/2 inch. I can touch the screen and I can go to 3/10 if I would like.
Okay.
Whatever, and then it'll change this number. It was at 2.4%, now it's at 4. So it's gonna run at 4% of its max.
So it knows what speed.
It knows exactly,
upon,
yeah, it's all calibrated with the drops. And one thing I should say too with an irrigation system, the drops, the holes where the water comes out is smallest, closest, because it's the smallest circle. And as you get further out, it's a larger circle. The end towers are moving way faster. You have larger openings in your drops.
More water as it travels
more
faster
water
across that
coming out.
arc.
Yep.
Gotcha.
Yep. And then there's many different programs that you can do. So I'm going to load the prescriptions. You go into programs, then you go into VRI. You want to go to VRI-IS, and then this is showing our demonstration prescription that we have, and then it should be enabled.
And you use an electric pump.
Yes.
And not diesel.
There are 4 wells manifolded together, shallow wells, less than 30 feet, or drilled wells with submersible pumps. It's probably almost a 1/2 mile away. This system, I believe, is designed for 600 gallons a minute. Every system is different. They're calibrated even on their drops, on their nozzle drops, for the amount of water you have available for your system. So you could have 1,000 gallons a minute, and then you would have to re-nozzle your system because it wouldn't be calibrated correctly. I do put rain gauges underneath these from time to time in the middle of the spans, just to make sure I'm getting the proper amount of water. You will have plug nozzles from time to time that you have to clean out. We do use our drone from time to time to fly the fields. Sometimes you will notice problems with certain drop nozzles or something just on the color of your crop. And you can see that really well with drone technology.
Cool.
Yeah.
That's awesome.
What I'll do to make sure that it's properly applying the water that I think it is, I will set out rain gauges. Not every system every year. Some of it is just you start to suspect that something's a little off.
You mentioned drones earlier too. The drones can see that sometimes?
Drones can see it. We had a system last year that we didn't notice there was a problem. It was in a cornfield. Your corn gets really tall, your drops are in your corn, and we got our yield map. And we were like, hey, there's a perfect circle here of a red spot.
And you can see that on the yield map.
We must have had a plug nozzle that we didn't know about because we couldn't see it. And so you go out in the spring and we have to find that plug nozzle. But the rain gauges are probably the most common thing that I use. We have done demonstrations here.
Like a uniformity test? Yeah, okay.
Yes. There's not a standard drop nozzle. There's many different variations of sprinklers for these systems, depending on your geography, where you're located, predominant winds, how open your field is. It can change the recommended drop nozzle for your system.
So how do you know when to water? That's always a good question, and I think you have some sensors out in the
We
field
have
too.
some soil moisture sensors. We have 3 of them on the farm right now. They also are on our AgSense app. So I have one out in the northwest pivot beans, and it's straight north of us right here. We've had a lot of rain recently.
Yep.
So it'll show you if your soil profile is full, or it'll go all the way down to red.
So blue is full.
Blue is
So I'm seeing blue all the way across
Yes.
the board. That's not a
So-
bad thing,
No, it just means you don't need to irrigate.
and
Plenty
you can
of
save a
moisture.
little bit of energy, not have to run
Plenty
the
of
system.
moisture in the soil. I also carry a probe with me, a step-in probe, that I go out and I always do it in the middle of a span. I don't do it next to the irrigator tracks because sometimes your watering is different. So I do it in the middle of the span, right in the row of the crop, doesn't matter what crop it is, and then it takes about a 10-inch core sample of the soil, and I just feel the top half and then the bottom half.
Okay, so it's a moisture by feel method.
Yeah, moisture by feel method, and I'm very comfortable with that.
Gotcha.
And
Do you find that the sensors that you have out here, are you more accurate than the sensors, or what do you find sometimes?
Well, my personal feeling on the sensors, and there's many different manufacturers of sensors.
Gotcha.
Last year was the first year we had them. I didn't irrigate as much as the sensors told me to.
Okay.
I thought that, one, we're trying to conserve water, and two, I'm like, well, I think I can make it another day. So then I did that. We were only permitted so many gallons or inches of water per acre or per system, and every system varies on those permits. So you can't go over those permits. There was no rain last year, so you're almost trying to ration your water.
Most areas of Minnesota were in a D3 drought last year, especially in this region.
Yeah.
So we were definitely in deficit.
Yes, we were in very much deficit, and nobody wants to water more than they have to. It costs money to run these things. There's a lot of repairs, and they're expensive. And then the energy cost is significant, and water's a resource. You don't want to use any more water than you have to either.
So what are we looking at here?
Here, Ryan, we have a soil moisture sensor. It's a probe that's stuck in the ground. You use a drill to install this. That's the same size as the hole. And it's a 2-foot probe that's going down into the soil profile. I believe they come as long as 4 foot, but you just drill a hole, push it down in, mount your stand. This catches your rain, and it'll compute your rain, or it'll keep track on the app, the AgSense app I showed you earlier. It'll keep track of that for 1 week. So it'll tell you how much water this has sensed for the last week. Then it's charged via mini solar panel. There is also a battery in here, and this will report to your phone.
Reports to your phone.
Yep.
So it measures rain, precipitation.
Yep. And
also
irrigation.
And irrigation that comes across
This
here.
is another tool, like we talked about rain gauges. If I have it set for a 1/2 inch and it goes across it,
and you get a 1/2 inch, you know you're
it's a 1/2 inch,
calibrated
I'm
on.
good.
Excellent. That probe is down here.
Yep.
And that does the same job as you carrying around your soil probe.
My soil probe, yep.
When we take this data, it helps you then as a farm manager to whether or not to irrigate, correct?
Yes. Yes. So I know roughly the amount of water that a crop is using per day.
Yep.
So then if I get 0.6 of an inch of rain, then I'll kind of know how long it will be until my next irrigation event. Sometimes too, it's common sense that your rain events vary. If you have nice soaking, soft rain, it soaks in really well. If you have 3 inches in an
drizzly
hour,
rains like we're getting right today here.
you have 3 inches in an hour, it all ends up in your potholes.
I imagine that this fills up pretty quick at 3 inches an hour.
Yep. This is a little lower, and we have a little more trouble in cornfields. When the pollen happens, this will fill up with pollen, and you'll have to clean it to get accurate readings.
Right, excellent. So as a farm manager, how does a precision irrigation system help you?
I think we're all after the same thing. I think farmers get a little bit of a bad rap sometimes. This is our livelihood. We have to take care of the ground, we have to take care of the water. This is how our life is made. So anything that we can do to conserve water or conserve electricity, cost is a huge factor. If we can be more efficient, every efficiency that you can have per acre, it drastically affects your bottom line, especially as farms get bigger and bigger. $1 an acre on a 2,000 acre farm is $2,000. You start getting $10 an acre, $15 an acre, well then it starts to become real money.
Reducing your inputs.
You're reducing your
for
inputs.
profitability.
And you know, when we're fertigating, and fertigating is putting nitrogen on through the pivot on certain crops, you don't want to be putting fertilizer out in a spot you don't want to be putting it. You don't want to be watering a spot where there's water already there, standing water. So the more of these systems that become available and in use, it's just amazing how the waste gets lessened.
Gotcha.
Just with the rain that we've received this year, we've probably cut our water usage in half. Last year was almost exclusively the water that the crop grew on came out of the irrigators. We were able to shave off with the technology. If you normally water every 3 days, if you went every 4, just because of technology, over a month's time, you would almost shave off 2.5 irrigation events.
Wow. That's a significant
it's
savings of
significant.
water.
Yes.
And energy.
And energy,
electricity.
yes.
That electric bill is probably a little bit less on those.
We have a meter for every one of our systems, and I do figure every year how much it costs each system to run. And some systems are more efficient than others, but this particular system, running on a year like last year, it cost me another almost $11 an acre to run the system versus a year like this year. So $11 times 110 acres.
Then when you add that up with the nitrogen costs
Yep.
and the increased seed costs and all those other costs out there,
Yeah.
your profitability decreases. So
does.
by having one of these systems, you can increase that bottom line, that,
Yeah.
that ROI.
Yep, because you're looking for any little thing that you can do to decrease costs.
Gotcha.
And it seems small, but all those small things add up.
I saw you had an app earlier where you could turn this thing on and off from your smartphone.
Yes, it's an app called AgSense, and it's a very good tool for us. We are able to track almost all of our systems. This particular system is the Northwest Pivot. So I can click on this and it'll download the most current information. It'll tell you where it's at in the field. The systems are all on 360-degree circles. Some systems don't make full circles, but it's all still on 0 is straight north.
Okay.
Now we have this current system sitting at 306 degrees, so it'll tell you where it is. Now we can put it in forward or reverse. We can turn the water on or off. Then we can set what they call stop and slot. So a full circle pivot will not have irrigator stops like you see sometimes on the end of a half circle. The only way to really stop it is to set a stop on a degree angle. So this one is currently set at 306 degrees. So it came to 306 degrees and it shut off.
So like if you're,
And you can do this remotely.
okay.
You can do this remotely.
So while you're out in the tractor, you can start up a pivot.
We do it
miles and
quite
miles
often while we're planting
while you're planting.
or doing tillage because these systems are in the field.
Gotcha.
And when you're planting and you're working one direction, you get closer to the pivot point, you can go on your
move it?
phone and you can move it out of the way.
That's pretty slick.
Yeah.
That saves it from sometimes.
Efficiencies because you're not shut down. Your
Gotcha.
pivot moves out of the way.
Any lessons learned in going from non-precision to a variable rate irrigation system?
As far as mechanical stuff, I haven't noticed anything yet. This is the third year with this system. It's been fairly trouble-free. Compared to our normal systems or the systems that have been around a while, the tower boxes are very different. We don't really know how to troubleshoot and repair. This particular system, or our variable rate system, has not been a problem. We do have a couple newer systems with the same boxes on. We've had some trouble. It's required us to get our dealer out to help us. We can't necessarily diagnose and fix ourselves. So we will learn. It's a learning curve. I will say 3 years, we haven't had any issues.
Let's say you're a newer farmer or is not doing variable rate irrigation. How do you get started? What would be your recommendation for them?
I would try to find any programs available that would help mitigate the cost of variable rate irrigation.
USD NRCS has worked with Central Lakes College. We've had multiple agreements now. I thought that worked very well. And part of that is that we provide internship opportunities for Minnesota students. Also, Ag 101 opportunities where students come in and learn about agriculture. Those are our employees that don't have an agricultural background, didn't grow up on a farm, and they get to come out to the farm and they get to ask questions and learn about things like crop rotation, tillage, different types of crops grown, the equipment too.
They get the opportunity to drive the equipment.
They get to drive. How cool is that?
Yep.
Drive a combine, one of the big quad tracks. I got to do that one year. That was super cool. So that's part of that relationship. Also through the college too, we've had project-based learning is what we call it, where students get to go out to NRCS projects and learn about conservation and agriculture and how those two can work together and see some conservation in action. Part of our collaboration together, our partnership together, is the field days that you guys provide too. And with that, we see things here like this center pivot system that's variable rate. We get to promote some of our financial assistance programs and conservation practices that we do. You do things like cover crops on the farm here too. You demonstrate all the different crop rotations. And these are things that we as NRCS have available for financial assistance. In the irrigation side of it, we offer variable rate through our practice called irrigation water management. We have variable rate irrigation scenarios to do the more high-tech items. We have irrigation sprinkler system practice where we can replace or retrofit existing systems that are less than efficient, maybe a high pressure system or a system that's met its lifespan and has leaks or just is not functioning properly. We can do things like those variable frequency drive motors that we talked about. We have that available through EQIP too, along with pipelines and things to get these types of irrigation systems out on the landscape. Why do we want that? These systems are way more efficient. They don't rely on a diesel engine, and they're more prescriptive. That zone application that we have that we talked about earlier is way more efficient. We're not over applying water where we don't need it, and we're not under applying water where it's needed. And that is the beauty of these precision agricultural irrigation systems. These conservation practices and financial assistance are available throughout Minnesota through our EQIP program. That stands for the Environmental Quality Incentives Program. If you're interested in things like precision irrigation, upgrading to maybe a low pressure system, replacing an old system that's not efficient, go visit your local office and talk to them about EQIP. See if that program is right for you. Irrigation efficiency and groundwater quantity are resource concerns that USDA NRCS addresses. The ability for us to save as much water as we can is important. And that's why we offer these practices, variable rate irrigation, more efficient type systems, to reduce the amount of groundwater that's used, and also to help save that bottom line of that farm too, that increased profitability. So it's a win-win situation. Taylor, do you want to introduce yourself and tell us what you do here on the farm?
Sure. I'm Taylor Thompson. I'm an ag technician here on the farm.
Can you tell us how this system has improved maybe farm profitability, ease of management?
Yeah, so everything we can do from on our phone, and the main thing with the precision irrigator is you have different soil types in the field, so you're not overwatering places, so you create a prescription which saves on your total gallons of water per year, and you're only allowed so many inches per year from the state.
Okay, so you're permitted for X amount of water?
Yep. So then with a prescription, you're saving that much water when you're in the low spots.
And of course, this is a very wet year, but in a dry year, does that help you to be able to apply water later when, let's say, that permit is running a little bit tight on the amount of water you can apply?
Yep, yeah. Based on like other standard pivots, this one would be able to have a little bit more because you're saving it throughout the whole year.
Fantastic. So that helps to make sure that you can apply that water later during those critical times when the crop needs that moisture.
Yep.
Now this is definitely a low pressure system, but what can you tell me about this system that would be different from, let's say, a standard center pivot system?
This one, it's a high speed system, so on like 90% dry, it moves at a very fast pace. So when I'm doing an application like spraying, I don't have to sit and wait for the pivot to move out of the way. This one it takes 5 minutes instead of half hour to move.
And that's valuable time, right?
Oh.
You want to get home to supper or whatever, and
Yep.
fantastic.
Yep, and then cuts on downtime too, so then I can get more acres sprayed in a day.
Perfect. If you were a newer farmer starting out and had a system and you were going to upgrade, what would you tell somebody about like going to a system that's a little more advanced like this one?
I would look at your NRCS type programs and see if you can cost share something like this. And then talk to your local dealer and see what it would all entail to get something up and going on an existing system, because you can adapt an original system to a precision irrigator, so you don't need a whole new system.
So you don't need to purchase the whole solid set system. And,
Yep.
And you'd probably have to run the numbers, right? Do
Yep.
the financials and economics on that.
Your return on investment on it.
Perfect. Like how much cost assistance could there be? How much does a new system cost or the upgrades cost? And then what the cost savings might be in energy and water too. I think
Yep.
those are important things for us to calculate into the mix.
Yep.
What can you tell us about the different crops that you grow out here?
We grow corn, soybeans, dark red kidney beans, and some small grain. This is our first year of doing a variable rate dark red kidney bean map out here.
Excellent. How would you say it's going this year?
Pretty good.
You also plant variable rate planting populations, and you have some technology when you're planting the crops here. Can you explain that to me?
Yeah, we do a soil test on this field. From there, we go to create a map based on our previous yield maps and our soil tests from the year, and decide if we want to lime, depending on where the soil tests come back. From there, we go to creating a seeding map, which is a compiled map of our soil map and our yield maps. So then that creates a confidence map, which we base on.
Yeah. So you create like zones, right?
Yep.
Like here's this zone that has X population. This zone's going to have maybe a higher or lower population based on like your yield capabilities,
Yep.
the
And
soil type.
soil types and elevation plays a huge key in these areas. From there, and then we send it to the tractor. The tractor and the planter do its job throughout the year, and there we go.
So as we're walking, we see that we have two separate fields. Does this center pivot system hit the cornfield too, or is it just for the dark red kidney bean field?
It hits both of them, and we can set where the pivot stops accordingly if we just want to water the corn versus the kidney beans.
And then you can set up two different zones, can't you? Like one for corn, which may take more water than maybe the kidney beans?
Yep. I can create a zone map based on what crop is there and the soil types.
Excellent. I like that. I mean, because certain crops may take different amount of water throughout the year. And if we have the ability to kind of change those zones, that's a pretty significant savings in water, electricity.
Yep.
And, you know, we talked about that permitting thing earlier too, where it's like, you know, if you're running late in the year, you want to make sure you have water to be able to apply during those critical time frames.
Yep, that rain insurance.
That rain insurance, I love that. And I know with corn, what at tassel is a pretty key point in drought years. If we don't have that available moisture during tassel, it can have a pretty significant impact on yield.
Oh, yeah, very much so.
Excellent. Other than irrigation, you're running some more precision implements, like do you do variable rate planters too, or?
Yep, so this field right here, we did a variable rate kidney bean field here.
Okay.
And this is our first year running a variable rate kidney bean prescription. But we do corn, soybeans, variable rate too on the farm here.
The variable rate irrigation, variable rate kidney bean planting populations, that's got to kind of complement each other, doesn't it?
Yep. So with this auto path, I got it set up so our cultivator can come in and we don't even have to steer down the rows. It just, you hit the button and you look behind and it's to the sub-inch accuracy.
That is fantastic.
Yep.
And then it also knows like how many seeds to plant per acre, all of that good stuff too. And then in the cab of the tractor, you got your screen and it's showing you everything, like where you've gone,
Yep, everything.
where you still need to plant.
Everything in real time. And then I also have an app on my phone and I can see what he's doing in real time too.
Awesome.
So, kind of keeping track of what's going on out there.
So you host field days out here. What are some things that you talk to farmers and ranchers about during your field days?
So new this year, we have a guy coming in to do aerial application on drones.
Wow.
So cover crop seeding to aerial or your fungicide over corn, and it's cheaper than an actual airplane.
Okay.
On the drone, he can spread cover crop mixes or he can apply chemicals. One value of a drone is you can, instead of having an airplane come in, you can have a drone operator come in and spray your crop that way, and it's a lot cheaper than an airplane.
I think that's the new wave of the future, right? Technology, smaller, faster, having drones do the work for us. That sounds fantastic.
Yep.
For drone technology with the application of herbicides or insecticides, pesticides, can that be spot spray or is that broadcast spray? How do they do that with drones?
So it can be both. It could be a spot spray or a full coverage of a field. Your spot spray would be more of your pasture lands, like spraying thistles, fence lines, so on and so forth. Your over the crop would be your weed kill throughout the year or your fungicides.
I could definitely see the benefits of having a drone come in and spray some herbicides on if you had just like a small patch of weeds pop up in a field. Instead of coming in there with a sprayer and doing a large broadcast area, you can kind of hit that, get over the top of the crops, hit those weeds and bring it back in. That's awesome.
And no wheel tracks.
No wheel tracks too. That's fantastic.
Yep. We go through some irrigation technology also that day.
Sounds like a great day.
Yep.
I want to say thank you on behalf of USDA NRCS for having us out on the farm. showing us some of this precision technology that you have, talking about variable rate irrigation, and also for being a working farmer growing food for us.
Yep.
Thank you. Thank you
No
once again.
problem. Appreciate it.
I want to give a huge shout out to our folks at Central Lakes College and the Ag and Energy Center for allowing us to be out here today, hosting events, teaching the public about irrigation systems, conservation, all those great things that you guys do, and for growing food.